So in 6.6 we have trapezoids and kites, and a trapezoid is a quadrilateral with exactly one pair of parallel sides. Here's an example of a trapezoid. The parallel sides would be the top and the bottom. We call those bases. And the sides of the trapezoids we call the legs. The mid segment or median of a trapezoid is a segment that connects the midpoints of the legs of the trapezoid. So if we had a line that went from this midpoint to that midpoint, that would be the median, or we also call it the mid segment. Its measure is equal to 1/2 the sum of the length of the bases. So this mid segment here would be equal to base 1 plus base 2 divided by 2. Okay. If the legs are congruent, meaning this side is congruent to that side, then the trapezoid is an isosceles trapezoid. In an isosceles trapezoid, both pairs of base angles are congruent and the diagonals are congruent. So this angle here would be congruent to this angle here in an isosceles trapezoid, which this is. And also this base angle at the top would be congruent to this base angle at the top in an isosceles trapezoid, which is where the two legs are congruent. So we're going to use these properties of trapezoids in order to solve problems. And here's the first one. We're given these vertices of the trapezoids shown here. We have point D over here. And so we want to show that the trapezoid is an isosceles trapezoid, whether it is or it is not, right? And so we could show that it is by using the slope. So what we would need to do is find the slopes of all of the sides. And so this line here, BC, his slope would need to be congruent to the same slope as the slope of AD, right? That would show that BC is parallel to AD. And so if we could show that, then we can show that it is a trapezoid, because that's what a trapezoid is, one pair of parallel sides. And then we also need to show that AB is not parallel to CD, right? So we're going to find the slope of AB. We're going to find the slope of CD as well. And if they're not parallel, then it's a trapezoid. Now the question is it an isosceles trapezoid? And we'll talk about that after we calculate the slopes of these lines. So we have AB, A and B. So the slope would be y2, 3, minus y1, so that's plus 1, over negative 1, plus 3. So that's 4 over 2, so that's equal to 2. Or 2 over 1. Right? And then we have AD, so that's negative 1, y2 minus y1, that's plus 1, over 4 plus 3. So that's going to be 0 over 7, or a slope of 0. Now we have BC, so it's going to be 3 minus 3 over 2 plus 1. 0 over 3, so that's equal to 0. Slope of CD would be negative 1 minus 3 over 4 minus 2, so it's negative 4 over 2, negative 2. Or negative 2 over 1. Right? Okay, so we're looking at the slope of BC, which is here, it's 0. And we're looking at the slope of AD, which is also 0. So these two are parallel, Right? We have one pair of parallel sides. The other pair of sides are not parallel. So this shape ABCD, this quadrilateral, is definitely a trapezoid. Right? One pair of parallel sides. This is what this has. Now, the question is it a isosceles trapezoid? Right. Now, to check if it's an isosceles trapezoid, we need the length of the legs. Right? So we need AB to be congruent to CD. All right. So to find the length of AB, we're going to be using the distance formula. So let's go ahead and do that. We'll do square root x. So this is A and B. So this is going to be the x's minus. So it's minus 1 plus 3 squared plus the y's. So it's going to be 3 plus 1 squared. So it's going to be the square root of 2 squared plus 4 squared. So it's going to be the square root of 4 plus 16. So it's going to be square root 20. Alright, so we'll do the same thing with CD. And so we'll do square root x's. So it's going to be 4 minus 2 squared plus negative 1 minus 3 squared. So it's going to be square root 2 squared plus negative 4 squared. So it's going to be the same thing. It's going to be square root 20. And so we've shown that it's definitely a trapezoid by comparing the slopes. And then it's isosceles because the legs have the same length of square root 20. Okay. So we're going to be using these different properties, and to sum it up, it's that in a trapezoid, the mid-segment, or the median, which connects the midpoints of SR and S and TU, is equal to base 1 plus base 2 divided by 2. All right, that's its length. And then if we have an isosceles trapezoid, which is that special trapezoid where the legs are congruent, and it looks like this, then the diagonals are congruent. The base angles, angle R and angle U, are congruent. Angle S and angle T are congruent. Yeah, and so those are the properties of the different types of trapezoids. And we're going to solve these problems using those properties. I'll show you the answers in the next video.